Hello everyone, welcome to Learn Data Structures and Algorithm in Python course. In today's lecture, we'll be discussing about a new topic called recursion. So before understanding recursion, let's first understand how a program executes. What I mean, let's take an example. Let's say you have to write a program to print numbers from 1 to 5. So 1, 2, 3, right? Then dot 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 5. Okay. You have to write a program to print number from 1 to 5. This is a simple program. Now how we can write? So let's say approach 1. So let's say solution 1. Okay. How we can write? One approach could be iterative approach, right? We can use loops. We can use loops here. Okay. How? Let's see. So let's first take a function def and name it as, let's say, print num, right? And what it will take? It will take a number, let's say n. And to print this, first we have to take a variable. We have to take a variable I equals to 1, right? Then let's say I am using a while loop. You can use for loop also. So while I is less than or equals to n, then do what? Print I, right? Print I. And when printing, then increment the I by 1. Okay, this is the problem. And let's say in the below we just invoke this print num. Okay, print num, then pass, let's say, 5. Then how it will execute? Let's understand one by one. Okay, step by step. Let's say initially n was 5. We passed argument n as 5. Okay, then initially it will create a variable I. Initially it will be 1. Okay, then it will check this condition. Okay, that means it'll go under this block. Okay, then what it will do? It will print this. It will print this. So it will print 1. It will print 1, right? That means it will print 1. Okay, this is done. Then what it will do? It will increment the I by 1, right? So then in the next step I will be 2. I will be 2. Then what will happen? Again it will go back to this, check this condition, right? So once it is done, once this block is done, what will happen? This will completely remove from our memory, right? Then for I equals to 2, again it will create a block code. Okay, then what it will do? It will print. So initially it was print 1, then again it will print 2, and again it will increment the I by 1. So I will be 3. Then when it has happened, this block will be removed, right? Then for 3 also, a new block will be created. A new block will be created, right? Then what will happen? Again it will print. This time I equals to 3, right? Print 3. So output will be 3. Then it will increment the I by 1. I equals to 4, right? Then what will happen? It will remove again. Okay, then again it will create a block and output will be 4. Then I will be incremented by 1. Then again this block will be removed. Then again it will create a block, output will be 5. I will be incremented by 1. I will be 6. But when I is 6, so this condition will be false, right? This condition will be false. So currently I is 6, but n is 5, right? So is this condition true? So 6 is less than equals to 5. Is this condition true? No, right? False. That means program will be, so this function is return, right? Function will return. Okay, so then from our memory this function will be removed. Okay, this function will be removed, and we'll get our output as, first it will be 1. First it will be 1, then it will print 2, then 3, then 4, then 5. Okay, this is iterative approach. Now let's consider a different approach. Let's say how we can do in different way. So let's say I create another function, so solution 2. Okay, so let's say solution 2. Okay, then here what we'll do? First I'll declare a function, so let's name it as same, print num. Okay, print num. Then what it will take? Let's say it will take I. Okay, let's take a variable I. This is actually a parameter. So what it will do? First it will check if I is greater than 5, then do nothing. then do nothing, just return. Okay, otherwise what we'll do, first print this I, print this I, then again call this function print num again. Okay, print num again, but this time pass this argument I plus 1, I plus 1. Why? We'll be understanding. So and at last we'll be invoking this function, right? We'll be invoking this function. So let's say we call this function print num. Okay, then initially pass I as 1. So let's say I equals to 1, right? Okay, then what will happen, what will happen, let's understand. When a program executes and see a function, then immediately in the memory it will create a functional stack, it will create a stack, right? Then how it will run, it will actually execute the code line by line. So first it will execute line number 1, then it will execute line number 2, followed by line number 3, then line number 4, so on. So what is the rule? It will execute from top to bottom, right? From line number 1 to line number 4, like that. And left to right, always from left to right, left to right. This is the rule. So from top to bottom, this is very, very important. And from left to right. Okay, left to right. Now let's see how it happens. Let's say for the first time we call this function. Okay, then what it will do, for so initially I will be 1, right? I will be 1. Then what it will do, it will execute line by line. First it will check this condition. Okay, so is I 1 greater than 5? No, right? So it will not execute line number 2. Then it will go to line number 3. Okay, line number 3. So let's do write like this. So at line number 3, what will happen, what will happen, it will print the number, right? So it will print, so let's say it will print 1. At line number 3 it will print 1. Okay, then it will go to line number 4. Okay, here you can see there is another function, right? Actually it is the same function, print number, but this time we are passing the argument as I plus 1. Then what will happen, then what will happen, in the line number 4 it will not execute it, it will pending, right? It will not execute, it will wait at this point. Okay, then what will happen, so it will call again a function. So this time I will be 2. Okay, then again in the memory there will be a functional stack will be created. So this time what will happen, so this time I will be 2, right? Then first it will check line number 1, because program always run from top to bottom, right? First it will check line number 1. So is 2 greater than 5? No, right? Then it will go to line number 3. So in line number 3 it will print this number. What will be the number? Number will be 2. Okay, done. Then it will go to line number 4. So in line number 4 what will happen, again we are calling a function, right? Again we are calling that function. So again it will create another element I equals to 3. Okay, then at line number 4 it will wait, it will wait for the result, it will wait for the result. So when this function will execute, then only this whole function will return, otherwise not, it will wait. So at I equals to 3 what will happen, first it will check this condition, is this condition true? No, right? So then it will go back to again line number 3, line number 3. So in line number 3 what it will do, it will print this I 3. Okay, 3. Then again at 4, line number 4, it will wait, it will wait for the further function. Okay, then again, so this time I'll be 4. Okay, then again at line number 3, line number 3 what it will do, it will print this number. So I will be 4. Then again it will go to line number 4. So at line number 4 it will call the function. So let's write it here, print num, this time pass argument as 5. Okay, done. So here again in the stack it will create another function block. So this time I'll be 5. Okay, then again it will check, is 5 greater than 5? No, right? It will not execute. So line number 3 will be executed, it will print 5. Then what will happen, it will again go to line number 4. Again it will call this function, so print num. then this time pass argument as 6. Okay, then what will happen? It will call again a function block, so it will create. So here see, at line number 1 it will check, is 6 greater than 5? Is 6 greater than 5? Yes, right, 6 greater than 5. So what will happen in line number check? First it will execute line number 1, it will check this condition. Now this condition is satisfied, right? This condition is satisfied. Then what will happen? Immediately it will return. It will return. That means from this block it will get the result here. Okay, so this function already got the result now. Then what will happen? From this stack, this means this code block has done execution. So in loop what was happening? For every parameter, for every I, so where first it will call the block, then block was removed, right, from the memory. But this time what is happening? Until the function doesn't execute, it will return nothing. Until then it will wait. Till then it will wait. So here also, until this 6, so print number 6, this function doesn't execute or return anything, it will wait for this, right? This is how a function works. Okay, so here it will return, right? It will return. So here this check 6 greater than 5, that means it will return. So immediately what happened? This will remove from our stack. Now we got our result here. So this function now executed. Okay, this function now executed. So yeah, this function now executed. So that means this is a great tick. Okay, then what will happen? It will return. Okay, it will return. That means for I equals to 5, this execution has done. Okay, so this print 5, this will be as it is, then this will be removed. That means it has done execution. So again it will return to here. It will return to here. Okay, line number 4. Then what will happen? Again this function has done execution, so this will be removed. This will be removed. Okay, this will be removed. Then when this has completed, then it will return here. It will call that this function has done execution. Then from stack also, this functional block will be removed. This functional block will be removed. Okay, then similarly when it is executed, then this block will be also removed. When a function returns something, then only the next function will be called. So this is done, so it will return, so that means this is done. So previously that was done. Now what will happen? The function stack will be empty. The function stack will be empty, and we'll be getting our result. First initially it will print 1, then 2. First it will print 1, then call the function to print 2. Okay, then it will wait for to execute this function. Okay, then when function 2 is called, so it will print 2, then call the function 3, and it will wait for function 3 to execute. When function 3 is called, it will print 3, then again it will call print 4, and it will wait. First then print 4 will print 4 and call this print number 5, this function, and wait. Okay, this print number 5 will first print the number 5, then call another function print 6. Then when print 6 will execute it, then only it will return. Then only this function returns. Okay, when this function returns, that means from function stack this will be removed. Again when this is done, this will return here. Till that, yes, this is execution is done. That means this will remove from our stack. Again when it is executed, then it will return to here, to function 3. Now it will be removed. Okay, then again similar process will happen, and at last this function will be executed, right? So that's how a function, even if a function call itself, how it will work. First it will create a memory, create a stack in the memory. Then whenever it will call itself, it will create a block by block, right? This is the order how it works. I hope now you have understood how it executes. Now let's say I change the order a little bit. That means line number 3 I put at line number 5. Okay, let's say, so first it was printing the I, right? Then what will happen? It was calling the function. But this time, let's say I remove this line. Okay, then write in the below. So right here, print I. Now let's understand how it happens. Now how it will do. Now how it will do. So let's remove this. So remove this. So for the first solution, what was happening? It was printing from 1, 2, 3, 4, like this order, right? Increasing order. Now let's see for this program how it actually runs. So let's remove them. Okay. So first what will happen? First what will happen? So yeah, create a stack here. Okay. So initially I will be 1, right? So I equals to 1. Okay. Then what will happen? First it will check. It will call this function, right? So this is line number 1. This is line number 2. This is now line number 3. This is line number 4. Okay. And okay, yeah, let's say first we call this function I equals to 1. Okay, then what will happen? First it will check, is I greater than 5? No, right? This line will not be executed. It will go to line number 3. Then in line number 3, what is happening? It will call another function. So in line number 3, it call another function, print number, and pass the argument as 2. Okay. So, but line number 4 is not executed yet. Line number 4 is not executed yet. Means in this line, it will wait. In this line, it will wait. It will not go to line number 4. So, what it will do? It will again create another function block. Okay. So, here in this stack. Okay. Then what will happen? So, this time I will be 2. Okay. So in this step, first step, it is not printing anything. Okay, it is calling the function again, but this time parameter is 2. Okay, so again what will happen? I equals to 2. First it will check this line, then this line, then this line number 3. So at line number 3, it is seeing that it calls another function. So this time I will be 3, I plus 1. Again for this line, the line number 4 will not be executed. Again it will create another function block. This time I will be 3. Okay, then again it will check. So 3 is greater than 5? No, right? That means again it will execute line number 3, but here also it will call another function 4. So line number 4 is also not going, because at line number 3 this program is pending, right? Waiting for the result. Then it will go here. Okay, then what will happen? Then it will again create another block. So this time I will be 4. So again at line number 3, it will call this function, and this time argument will be 5. Again line number 4 will not be executed. It will wait for this result. First execute this function, then it will go back to next line, right? So again it will create another function block. So this time I will be 5. Okay, then at I will be 5. So this line 3 will be executed. Okay, it will call print number 6. So first it has to be done its execution, then it will go and it will create, let's say, let's remove this, another block. Okay, another block I equals to 6. Now here I equals to 6, that means this first line, so 6 greater than 5. Yes, 6 greater than 5, right? So it will check first line number 1, then line number 2. Line number 2, what is happening? It is returning, right? It is returning. So even if you don't write, like let's say right here also, plus let's say return, uh, return, and let's consider this as line number 5. Okay, then it will be clear. Okay, now what will happen here? First line number 1 will be executed, line number 2 will be executed. Okay, line number 2 means it will return. That means that means this function block has done its operation, then it will return here. Okay, that means from the stack it will remove this functional block, will be removed. Okay, then it will go back to here at line number 3. Okay, line number 3, then it will say that this print number 6, this function has done execution. So print number 6, so at line number 3, this function has done its execution. That means go back to the next line, go back to next line. Now at line number 4, so it will run line number 4. So in line number 4, what is happening? line number 4, let's remove this part. So in line number 4, what is happening? For I equals to 5, it will print the number, right? So it will print 5. It will print 5. Previously, first it was printing, then it was calling the function. But here, first it was calling the function, then it is printing. Okay, it prints 5, then it is done, right? Then what will happen? It will go to line number 5. In line number 5, what is there? Return. So again, it will return from here to here, return from here to here, here to here. That means this block will be removed. This will be removed. Okay, this will be removed. For I equals to 5, it is done. For I equals to 5, it is done. Okay, this function has done execution, right? This is right. Okay, then line number 4. In line number 4, what will happen? It will print the number 4. Okay, so it will print the number 4. That means line number 4 has done execution. Then what will happen? It will return from here. That means from here it will return again. Okay, then this block will be removed, right? This block will be removed, and going so on. So here also, so if it is done, then it will say that this function has done execution. That then just print the number. So it will print 3, and this block will be removed. For I equals to 3, this block will be removed, and it will return from here to here, from here to here. Okay, then this is done. Then what will happen? Go to line number 4. It will print number 2. Okay, then what will happen? Again, it will print number 2, and it will return from here to here. It will return from here to here, right? From here to here. Okay, then again this function block will be removed from here, and here it is done. Then line number 4 will be executed. So in line number 4, what is there? You have to print 1, right? Then after printing 1, it will finally return, means this function stack will be empty. Now this time, what will be the output? Output will be in reverse order. First it will print 5, then 4, then 3, then 2, then 1, then 1, right? Then 1. So what is happening? This is happening because we are interchanging the line. So we just write this print I in spite of line number 3, we just printing it line number 4. So that is the difference. If you call the function first, then you call the operation at last, do the operation at last, then order will be completely changed. Initially it was printing from 1 to 5, but this time it is printing from reverse order, from 5 to 1, right? But you may ask what we are actually doing here. So here, so here, to solve a particular problem, we are solving the problem again and again. What I mean? Now here to solve this particular problem, we are solving the same problem. We are solving the same problem. But this time the argument is different. We are solving the same problem, right? Again and again, again and again. This is actually called recursion. Recursion. Right, this process is called recursion. So recursion means to solve a problem when you solving the problem again and again, again and again. This is called basically recursion. This is actually recursion. And what is a recursive function? What is a recursive function? A recursive function is a function that calls itself. So here you can see, to solve this problem, so solve this function, we are calling this function again and again, right? So this is called function, recursive function, but the process is called recursion, right? So what is recursive function? A recursive function is a function that calls itself inside its own definition, right? Inside its own definition. So that is basically what is recursion. And in recursion, there are three things. There are three things you have to remember. So here you can see. So let's remove this. Okay. Recursion basically have three steps. One step is one step is one step is we have to check where to stop. We have to check where to stop. This is called base case. Base case. Okay. Then Then another thing is do some operation. Here we are just simply printing the number, right? But here in this part we'll be doing some operation, right? So here let's say do some operation. Okay, do some operation. First we have to check the base cases where to stop the execution. Then do some operation. We'll be doing some operation here. Then at the last step, what we'll do, we'll call the function again. So call the function again. Okay, again. So these are basically three steps. First is to check base case, then two is do some operation, then three call the function again. That is the simple step. And last we have to return, right? So this is all about recursion, how we can approach. So why the base case is needed? Let's say we remove the base case. Let's say we remove the base case. Then what will happen? Then what will happen? So first, let's say we provide. So let's say initially. So let's say we invoke this function as print num. Okay, and pass one. So first it will call, right? Then it will print one here. Then what will do? It will increment I by one, right? Then again call the function. Then when the function calls, then again it will print two. Then again it will call, it will print three, print four, print five. But function doesn't know. But function doesn't know where to stop. So where to stop? There we have written that if, so this was the condition. If I greater than 5, then just stop. Then just stop. That means return. So here we have given the stop cases, right? Where the program has to be stopped. But if we don't provide this condition, so it will continue running again and again. It will fall in an infinite loop, right? So what it will cause, it will first create function blocks like this, like in stack it will create like this. So at a certain period, this function stack will be full. This function stack will be full. Then after that, you can't do this operation again, right? This condition is called stack overflow. This condition is stack overflow. That means our program, our function has fall in infinite loop. That is called causing stack overflow. To stop this, we need this base cases. Where to stop execution, right? So in recursion, they are basically three steps. They are basically three steps. Now, one question may arise. So this same problem, the same problem, we can solve using iterative approach, right? We can solve using loop. Then why to use recursion? What is the advantage or what is the disadvantages? So when you solve a problem like tree or graph data structure, right? There you can see we'll be using this recursion technique. That is very, very helpful. That is very, very helpful. But the problem in recursion is it is very, very it consumes so much memory, right? Every time you see, it will create a function block, right, in the stack. So it is not that much memory efficient. So when we see we can solve the problem using iterative approach using loop, then we'll try to solve using loop. But where we'll see that in spite of recursion, without using recursion we can't solve. There only we have to solve using recursion, right? So time complexity for recursion also is very large, right? That's why most of the time we'll try to avoid recursion, right? Now I hope how what is basically recursion is and how we can convert whatever we can write in the loop using loop, that we can also write using recursion technique, right? I hope so you have understood what is recursion.